Want to learn GraphQL from scratch with React, Node, MongoDB, and Firebase? Then join me in this course. Here I will help you learn GraphQL in fun and easy learning environment. You will learn GraphQL from the very beginning, building a fully functioning real-time web app while learning all the essential features of GraphQL. The goal of this course is to give you all the theoretical and practical knowledge necessary to start your next big project using GraphQL. We will also be using latest React hooks along with a GraphQL, React Router, and Context API. Instead of writing our own authentication system, we will use Firebase just for handling authentication. So you will build a real-world authentication system that includes password forgot, reset, confirmation email, refresh tokens, and social login. So if you're looking to build next level apps using GraphQL, don't waste your valuable time wandering around and trying to learn it from 10 different resources. I have packed everything into this course for you to fully understand all the practical GraphQL concepts, from basic to advanced and all the way to real-time subscriptions. Ready to go full stack GraphQL with Node, React, MongoDB, Firebase authentication, CRUD, real-time subscription, deployment, and more? Then join me in this course. Before we dive into GraphQL, it's better to get at least a very basic understanding of what it is about. So GraphQL is a tool for client-server communication. In simple terms, GraphQL is a query language. So GraphQL query is sent from the client side, for example, a React application, to the backend server, which is also built using GraphQL. So you can send such requests, such queries using any HTTP clients like Axios or Fetch, or you can use more advanced tools like Apollo GraphQL queries. All right. So here you can see example of a query. So for example, if you want to get a user information from your backend server, so you want to get the user with the ID of 5, and you want to get this user's name, email, and created at date, then this is how you will send a query from your GraphQL client to your GraphQL server. So if it was a REST API, it would be something like your domain.com/users/5. Probably this is how you would send a request to get the user with the ID of 5 and get its information if it was REST API. But with GraphQL, this is how we send a query. All right. So once you send a query like this, GraphQL server will send you the response, a JSON response. So let's have a look at that. So GraphQL is a runtime for fulfilling queries with your data. So as you can see here, it is a query language. We send a query like this, and then GraphQL, because it is a runtime for fulfilling queries with your data, whatever data you ask, for example, user with the name, email, and created at, when you ask like that, this is the response you get. So JSON data with is returned from GraphQL server, and GraphQL server is built using GraphQL types, resolvers, all that we will learn in this course, along with existing server-side tools such as Node, MongoDB, Express, and other NPM packages. So when we say GraphQL server, it is not entirely built with GraphQL on its own. Okay, we will still be using the existing tools. So database we will have Node.js, Express, other NPM packages, everything will be there, but GraphQL will be wrapping the entire thing. So basically at the heart of GraphQL there are types and resolvers. We will cover obviously in this course in step-by-step manner, but the bottom line is you send a query like so and you get a response like so, exactly what you ask for. You ask for name, email, and created at date, and you get that information like so. Now one more thing about GraphQL, it is usually served over HTTP and WebSockets. All right. So as you can see, we already talked about that. We know that GraphQL queries can be sent from client using Axios, Fetch, or using some advanced tools like Apollo GraphQL. And GraphQL also served over WebSockets as well. So you will send queries to access data like so, just like a GET request if you were using a REST API. So that's queries, and there are other types such as mutation. So mutation is basically when you mutate the data in the server. For example, when you make a post request using a REST API, you update and delete the data in the backend, right? So for doing anything like that, you will use mutation types. So they look basically same, but there are slight differences. So when you want the data, you send queries. When you want to update or delete data, you send mutations. And there is another type called subscription as well, which enables us to communicate with our server using WebSockets. Okay, so that is another really exciting thing about GraphQL. So using HTTP or HTTPS, it can be served, as well as using WebSockets for real-time subscriptions. So with this basic information, let's go ahead and give it a try. There are some online open source tools that allows us to play with GraphQL and see how we can query the data. Let's give that a try before we start writing our own GraphQL server. Before we start writing our own GraphQL server, we can try making some GraphQL queries and make ourselves comfortable. Okay. And there are some online resources out there. For example, you can search for GraphQL Star Wars API, and there you can try to make some queries. It is open source GraphQL API, and we can give this a try. However, this is completely optional. Okay, so by the time you're watching this lecture, I'm pretty sure it will be available, but if for some reason it is not available, that's completely fine. You don't need to even try this with me. I'm just going to demonstrate to you how we can make some GraphQL queries. All right, so let's try this playground. For example, we can make a query to get a person by the ID of 1. Maybe we want to get some information out of that person. For example, his name, birth year, eye color, and so on. Let's see how we can try this, make such queries in GraphQL. All right. So this is completely optional. You don't have to do it with me, but if you want, feel free to try it with me. All right. So let's search for Star Wars GraphQL API. Okay, this is the one. And let's click here. Okay, so here we can just play around with GraphQL, make some queries, and get a feel for it. Okay, so let me select all, get rid of that. So one of the beauty of GraphQL is it auto generates the documentation. So for example, you are here, but you don't know what data you can access, right? You don't know, but that's fine. You can just click here, the docs. Okay, it will be automatically generated by GraphQL, and you can see we have one root query. Okay, so you can click here and see what options are available. So if you click here, you can see all this information. So it shows you that you can query to get all the films. You can query to get a particular film with the ID of the movie, ID of the film. You can query for all people, person, all this information. So why don't we stick with our example? Let's query a person by the ID of 1. Okay, so here when you want to make a query, you write query. Okay, and as you can see, it auto populates as well to make things easier. Query, curly braces, and here you will write your query. For example, I want to get a person. Okay, person, parenthesis, we need to send the ID because you can see it is a requirement. So we need to pass the ID as an argument. So ID, let's say 5. All right, and then the person ID also required. Okay, so person ID also, let's say 5. Okay, so with all that, we have the query, we have the arguments, but we also need to make sure what data we want to get in return. So here in the curly braces, we define what information we want from this person, and you can see after the semicolon we have this person type. click here and you will see what information you can ask for from this person. So if you click here, you can see we can ask for name, birth year, eye color, gender, and so on. So let's give them a try. Let's say name. Let's say we want birth year. Let's say eye color, and so on. You can just go on and on. All right, so on. So this is how we can make a query. Okay, so let's give this a try. Let's hit play button. Okay, and we get the information, exactly what we asked for. We asked for person by the ID of 5, we got that, and we got all this information: the name, birth year, color, gender, and hair color, so on. So this is how we can make a GraphQL query. Beautiful. All right, let's try one more. The beauty of GraphQL comes in when you need to query the nested data. So for example, if you're using REST API, things can get quite complicated as it starts to grow, right? So here, nested queries, we can query for all the movies, then get a single film, then get that film's title, director, release date. Then you can also ask for the species collection of that film, okay, and then the total number of that, and then the species themselves and their information as well. So you can see the queries are nested so deep. Now, making such queries with REST API is also absolutely possible, but in situations you might have to make multiple queries. For example, you might make a first query to get all the films, okay, and then you get all the films here, you get this information, but then you need to get the species collection as well. Then you might have to make another GET request to your REST API with the films / the film ID, and then the species collection you will get, okay, and then you might need to go one step further to get individual species information. So you can see here with GraphQL, it is really easy to query. Obviously we have to do some work in the server side, but making queries to get the information to your client is absolutely beautiful with GraphQL. However, things can get quite complicated with REST API. So we will actually see and experience how everything works and how it differs with REST API and how it makes your life easier. However, you see the nested queries we can make like so. Right? So being able to make such queries help us avoid multiple requests to server. This is one of the strengths of GraphQL over REST API. Okay, so we can give this a try. Let's try for all movies. Let's make another query. Let's get rid of that query. And if we're not sure, let's have a look at the docs. Let's have a look at the root queries and all films, right? All films. So when we ask for all films, we can pass these arguments. They are not mandatory. This gives us this films connection. So we don't know what information is there. So let's have a look here by clicking. So we can see we get the page info, total count, films, and all this. So let's try. Let's try total count. Get films. Okay. Now these films, you can see here, total count is written integer, so we don't need to go and do anything like that because there is no such information. It's just integer. However, films returns the film type. Okay, so when you query for the films, you need to select what information you want. Just like with person, we select name, birth year, and so on. So when you query for films, what do you want? Okay, let's have a look here. Let's click here with the to the film type. So these are custom types. Okay, so with GraphQL you have queries, mutation, as well as you can build your own types. So you can see here they have film type. So let's try this. Okay, so this film type gives us all this information: title, director, producers. Let's try some of them. Title, director, okay, release date. Okay, let's try that. And species connection. Let's try that as well. Species connection. Okay, now as soon as you try this species connection, it has this film species connection type as well. Okay, so these ones, release date, director, they are single return string type. Okay, some of them are integer type, so we don't need to do anything like that. Okay, there is no such nested information. That will just give us the string type or integer type. However, when you go to the species connection, it has this type. Okay, so we need to click here and have a look what information we can query. So let's click here, and you can see here we have all this information to query. For example, page info, ages, total count, species. Let's try some of them. Let's try total count, and let's try species. Okay, now total count, we don't need to select anything, it's integer type, that's fine, that will give us some total count. However, when we want to access species, you can already see here that there is a species type as well. It has a list of all the objects returned in this connection. So let's click here. Okay, so in the species type, we can query for the name, classification, average height, eye color, so on. So you can see here, let's try name, and let's say classification. Okay, so this is the beauty of GraphQL, you can see here. Now let's query, and you can see we got all the data we asked for. We got all the movies, total counts, we got 7 movies, and we have the movies films array. And then each films, they have the title, director, release date, species connection, total count, and the species themselves. The species, we selected the name and classification, and we got all that. All right, so this is GraphQL queries. This is how you query your server and get beautiful JSON response. Okay, so now you got some understanding, and you are feeling a bit more comfortable with GraphQL, I'm pretty sure. And it would be awesome to build our own GraphQL server and being able to query the information like so, right? No problem. That's what we're going to do it in this course. So let's go ahead and let's kickstart writing our own GraphQL server very soon. Before we start coding, let's go through the final lecture where we're going to talk a bit more about GraphQL. So why GraphQL is awesome? You must have heard that everyone is talking about GraphQL, right? So why is that? Well, there are many things, and you will actually experience the difference and experience what GraphQL brings on the table as you continue with this course. But let me give you some overview, right? So GraphQL is awesome for many reasons. One of the reasons I think is because one single endpoint it has, unlike multiple endpoints of REST API. In REST API, you use the different endpoints, but with GraphQL, you use different types, okay? And then you query those types, right? Another point is real-time communication, which is one of the most exciting reason for me to jump into GraphQL. Right? So real-time communication using graphql-subscription, we can implement that. So our client and server can be instantly in sync using WebSockets, using a subscription that is using WebSockets behind the scene. Right? Another reason is easy and declarative query data fetching. So when we say declarative, we ask for what data we need, nothing more, nothing less. For example, in some situation with REST API, sometimes you might want just one bit of information. For example, you might want just person's username, but instead you might get the entire person's information, his name, his other information, his related post, the entire collection you might get. In a situation like that, with GraphQL, you can be declarative and ask what do you exactly need, no more, no less. That's possible using GraphQL queries. And another exciting thing about GraphQL is auto-generated docs. We already tried in the previous lecture. The GraphQL playground gives you the auto-generated docs, which makes it really easy for your front-end developers to see how they can query the database and get all the information from the server. So it makes it really easy for the front-end devs to work with the server side of the application. All right, now how it compares with REST. So REST API usually uses 4 types of HTTP verbs: get, post, put, and delete to perform CRUD operations, which is the basis of almost all the web apps on the web, you can see. So create, read, update, and delete. REST uses these methods, right? Get, post, put, and delete. So get method is used to read or access data. Post, put, and delete is used to create, update, or delete the data source in the backend or the database, right? Now, it's almost similar to GraphQL, almost. At the heart of GraphQL, there are types: query type, mutation type, and subscription type. Okay, so GraphQL uses two types, queries and mutation, to perform CRUD. For example, you are used to REST API and now you are working with GraphQL. The easiest way to understand is understanding the CRUD. For example, in REST, you have these methods to implement CRUD. So you might ask, how do you do it with GraphQL? Okay, so you do it with GraphQL using these two types of queries and mutation. So queries used to read or access data, similar to GET request in the REST API. But for everything else, mutations are used. So the mutation types are used to create, update, and delete, okay, in GraphQL, which is similar to post, put, and delete in REST API. So you see here, get, anytime you want to get information, you use queries. Anything else, for example, post, put, delete, you use mutation. Simple as that. And subscription is obviously for real-time communication, which we will cover a bit later in the course. So both REST and GraphQL uses WebSockets for real-time communication when it is necessary. So GraphQL calls it subscription type. Now, finally, we will be coding very soon. Let me go through this, right? So it is time for us to start coding our GraphQL server with Node, Express, and MongoDB. Then we will move on to building GraphQL client with React. Okay, so this is basically the overview of what we're going to do in this course. So all the theories will be covered in a step-by-step manner as the course progresses, because when you're trying to learn something new, sometimes you might have so many questions. How do you do this? How do you do that? Right? So just trust me and take it easy and start continue this course from start to finish. By the end of the course, you will get all the information necessary to build your next big project with GraphQL. But if you have too many questions, sometimes it doesn't really help in the learning process. Okay, so trust me and go through the course from beginning to end. You will learn pretty much everything you want to know about GraphQL. Okay, so all the theories will be covered in a step-by-step manner as the course progresses. So be patient and enjoy the journey until the end of the course. Okay, so you will get enough knowledge to build your next big project using GraphQL with complete understanding of each concepts covered in this course. All the code you will write in this course can be used as a reference as well. So when you want to start your next project, you don't have to play the video lectures again and again to understand, because it always happens. You understand something, you followed my course and you did it well, perfect. But after a week, you want to implement something similar in your next project. In that case, you can just have a look in the code base and you will understand. You don't have to go through the video lectures again and again. Okay. So when you start building your own project after completing the course, you will have easy time ahead. As a bonus, you will also have a fully functioning rock-solid authentication system backed by Firebase. This is another exciting thing I've done in this course, because I have made many courses before and all of them spend so many hours just building authentication system. And still they might not be the best, because when it comes to authentication system, it is a very complicated topic. You want to implement so many features, for example, forgot password, reset password, sending confirmation email, and even most importantly, refresh tokens. For example, once the token expires after 1 day or 1 week, what do you do? With Firebase, it is incredibly easy. It's really easy. You don't have to do anything. Everything is handled by Firebase. You just implement in your client side and you get social login, automatically refresh token. So every 60 minutes they generate a refresh token. So it's perfect. And not only that, we will implement in the client side. We will also validate the token in the server side as well. Okay, so when we authenticate the user in the client side, then we send that token to our server, do further operations. For example, user will be able to create, update, and delete in our database Now, before we allow them to do that, we're not just going to hope that the JSON token that we're getting from the client is the valid one. So we also need to make sure that we check against Firebase. We make another request to Firebase admin and make sure that the Firebase token that we're getting from our client side to server side is a valid Firebase token. Okay, so we will have that in the server side as well. So it is fully rock solid authentication system, which you can use in any of your projects. It doesn't even have to be GraphQL. It can be a REST API. It can be anything. Okay, so this is one of the beauty of this course. Okay, and then I will talk more about it in future lessons. Obviously, if you're a bit overwhelmed, I'm talking 2 months, don't worry, take it easy, right? Everything is done in a step-by-step manner. It's really easy to understand. So just so you know, Firebase is used only for authentication, nothing else. So you must know that Firebase, even though it is exciting, over time it can cost you a lot, right? But authentication is completely free, so you will never be charged for using Firebase authentication. So we will use Firebase for that, and then we do everything else with our own server. So everything else will be happening with our own GraphQL server and MongoDB. Now, enough talking, let's get to coding from the very next lecture. In this lecture, we're going to set up our server. So we will build a server first, GraphQL server, and then we will move on to front end and build GraphQL client with React. All right, so in this lecture, let's set up a basic server. We're not even going to worry about GraphQL for this lecture. We're going to install GraphQL in the next lecture. In this lecture, let's just get the server set up. So decide where do you want to create this project. I'm going to create here inside the Udemy folder right here. Okay, so let's open the terminal window. Okay, so I'm going to navigate to Udemy folder, and there I have this existing folder called old. I'm going to create a new project. Now I'm pretty sure you have Node installed. Okay, if you don't have, you need to install Node from nodejs.org. You can go there and download. If you have Node installed, you can check by checking the version. I'm currently using the version 12. So let's create a folder for our server. Make directory, let's call it server. Okay, get inside server, and then we need to initialize our project with npm. Okay, so npm init and -y flag to accept all these default values. Okay, so by default, all these values are added to our package.json file, which you can see here, package.json. Let's actually open this in our code editor, and I'll be using Sublime Text for this course. But whichever you're using, VS Code, Sublime, or anything else, it doesn't really matter. It's going to be exactly same. All right, so let's have a look at the package.json file, and you can see here we passed the y flag, and as a result we got all these default values here. So the name, version, description, and so on. Now, first thing we want to do is add some npm packages. For example, to create a node server, we're going to use Express. So npm install Express, and we're also going to use the package .env so that we can load environment variables, and also node-mon so that we can continuously run our node server. While it's happening, we can go to our project. Actually, it's already done here, and you can see these packages have been installed here: .env, Express, and node-mon. Now we can go ahead and write our Express server. So here in the root, let's create a new file called .env so that we can put some environment variables here. Okay, so here let's write port. Port will be used by our Express server on which port we want to run our Express application. So let's say 8000. Okay, so that's all we want in our env file for now. Let's close this and let's start creating the entry point for our server. So here, let's create a new file. Let's call it server.js. All right, so here, first thing we want to do is we want to import Express, which we have already installed. So let's require that const express equals to require Express, and we also want to require env so that we can use that environment variable. So require .env, and we execute the config method that is available with this package. Okay, so with this we'll be able to use environment variables. All right, now let's create a express server, const app, let's call it, and invoke express. So here, as you can see, I'm invoking express, which means I have the express server available in this app variable. And basically express, you can think of express as a request response handler. You get the request from the client side, and our application will send the response. So we got express here in the variable called app. Now with this express, we get a lot of properties and methods that we can use. One of those is get. People requesting to the REST endpoint, for example, if they are sending requests to REST or API, or it could be anything. So what do we want to do? We want to send some response, right? So that's how it works. The get method takes the first argument as the endpoint. What endpoint? So in this case, our endpoint is going to be /rest. So when we get any request to this endpoint, what do we want to do? We want to send some JSON response, let's say. So here in the second argument is going to be a callback function. Okay, so function has access to the request response object of this express app. So request and response, let's say we want to send the JSON response. So response.json. So we get this method JSON with this response object. So we can send the data, and let's say you hit REST endpoint or something like that. All right, so this is how you would build a REST API as well. The reason I'm showing this to you is because when you build a GraphQL API, it doesn't mean that you have to be only dealing with GraphQL. You can also use REST endpoints. You can build your REST API at the same time, and you still have the GraphQL server as well. And in some situations, you might want to use some REST endpoints instead of GraphQL. Okay, completely optional. I'm showing you here, so if you need to utilize some REST endpoints later, you can easily do that. Now we can utilize the port that we have here in the env file, port 8000. That's where we want to listen. Our server wants to listen. Okay, so port. Let me also have some comments here. Express server, we create the express server here. This is the REST endpoint. Okay, so port, we want to listen to port 8000. So app.listen. So again, this express app gives us this method called listen, where you can pass a couple of arguments. The first argument is the port. Okay, so you can access the environment variable using process.env.port. Okay, so that's the first argument we give to this listen method, and that is all we need to do. But if you want, you can even write a callback function here and maybe just do some console log function, console log, and let's use backticks, which is on the top left, right below the escape tab. Okay, this is not quote, this is backticks. So let's write something like server is ready at http://localhost : embed the port here. So $ curly brace, embed this variable. So this way, Express server is listening on the port 8000, and we have the console log. All right. Now we can run our server, but before we do that, we need to make a small change in the package.json file. Here you can see we have scripts, and at the moment there is only a test script. We don't need that, so let's change that to start. All right, and here when we run npm start in the terminal, what we want to do, we want to execute this server.js file, right? So we can do server.js, and we can use node to execute server.js. The downside of this one is anytime you make any changes, you have to stop the server and restart, and that is not something we want. And that is the reason why we install node-mon. So with node-mon, you don't need to stop the server and restart every time you make some changes in your application. Now with this start script, we can go to our terminal here inside server folder, and we can run npm start, and that will start our server. And you can see we have the console log as well. So that means we have our server up and running, and not only that, we even have the REST endpoint which will send some JSON response. Let's give this a try. Okay, let's try localhost 8000. Okay, now if you just hit 8000, you will get something like this, which means the server is running but there is no data here. So we don't have the get / endpoint. However, we have REST endpoint. Okay, if you do that, you get the data, the JSON response we are sending from our backend. Great. Give it a refresh. You can see it's working. Okay, so this is how you can create Express server that handles the REST endpoint. But obviously we are here to learn GraphQL. No problem. In the next lecture, we're going to bring in GraphQL and see how we can integrate GraphQL with our Express app. And please make sure to restart your server if you have made any changes in the env file. Okay, so whenever you make any changes in the env file, you need to restart your server. Before I end this lesson, let me do one more thing here, and that is, at the moment you can see this is the folder we're working on, but later there's going to be a client folder as well. So it's a best practice to put both of them in a single folder. So let me create a new folder called, let's call it GraphQL, and I'm going to just simply drag that server here in the GraphQL. And later I will be creating another folder called client for React application here. So everything is inside this GraphQL folder. Now if you have the terminal open, go back. Okay, make sure to go back and get inside GraphQL. That's the folder we're using now. cd GraphQL, and then we have the server. So cd server npm start. Our server is running here, localhost 8000/rest. Beautiful. In the previous lecture, you saw how we could create Express server. Now in this lecture, let's go ahead and create a GraphQL server. We're not going to worry about Express or anything. We just purely create a GraphQL server using Apollo GraphQL. In the lecture after this, we will see how we can combine Apollo GraphQL with Express so that we can take benefit of both Express, implement a couple of endpoints, REST endpoints if we need to, and also take benefit of having a fully functioning GraphQL server. Now, before we do anything further, let me quickly take it to Apollo GraphQL. Here you can search for Apollo GraphQL. All right, let's click here. So here you can see it simplifies the app development by combining APIs, database, microservices into a single data graph that you can query with GraphQL. Okay, so if that doesn't make much sense, let's have a look in the docs here. And here you can see the first thing they say is Apollo is a platform for building data graph, a communication layer that seamlessly connects your application client, such as React or iOS apps, to your backend server. So instead of using raw GraphQL, let me quickly take you to graphql.com.org. Okay, so GraphQL can be used not only with the Node, Express, or JavaScript stack. It can be used with many other programming languages such as PHP, Python, and so on. So there are libraries available that helps you integrate GraphQL with any other language. But since we are using Node, Express, the JavaScript stack, we are using Apollo GraphQL, which makes the entire process extremely simple. Okay, so that is the reason why instead of using raw GraphQL, we will be using Apollo GraphQL. So to start building our own Apollo GraphQL server, we need to install a package Apollo server, which might be here in the docs as well. Let me search for server, Apollo server. Okay, so get started with Apollo server. All right, so create a directory, get inside, and install Apollo server, the core library for Apollo server itself. All right. So these are two packages. One is Apollo Server, another is GraphQL. Let's install that in our project. So let me go to my terminal. Let me stop it for now and npm install Apollo Server and GraphQL. Alright, while that's happening, let me create another file. Later we're going to integrate both into one, but I want to leave it as it is, this Express server, and let's create another server just so that we can see how we can build Apollo Server completely without using Express. Okay, so let me rename it GraphQL server.js. Okay, so the first thing you want to do is import Apollo Server. So let's bring in const Apollo Server require Apollo Server, and we also need to require the .env just like we did here. So let's grab that and use here. Okay, so to create a GraphQL server, there are two minimum requirements. So you need to define the types, which could be query type, mutation type, subscription type, and type. So you need types and you need resolvers. Okay, so GraphQL server, you need types and you need resolvers. So in types you will write your query, okay, and then in the resolvers you will write a function that will resolve your query, because just by writing a query there is no way that we can return some data to the client. Okay, so we still need to do some work in the server side. So that's what happens in the resolver function. So these types, they can be query type or mutation type or subscription type, or any of these can be your own custom types as well, which will also be covered later on in the course. Okay, so you will write a query type, a mutation type, and you will write a resolver that will resolve that query or mutation. Okay, so let's give this a try. Let's write our very first query. So let's put it in a variable const type defs. So here we're going to use backticks. Okay, so they are right below the escape key in your keyboard. So type definition or insert term type defs. So let's write a query type. So type query with the capital Q. Okay, so we're going to write a query type, and we just want to write a very simple query. Let's say we want to get the number of total posts that we have. Okay, so we will write our query. Let's call it total posts. Okay, so when we query the total post, we want to get the number in return, nothing else, just a number. So we want to get back the integer type, right? And we want to make sure that it is not empty or null. So in that case you will use exclamation mark. So this indicates that this cannot be null. So this is our query. Okay, so that's fine, we got the query, but nothing will happen unless we have a resolver function with this name. This is the name of the query, right? So we still need to have a resolver function with the same name that will resolve this query. So here we can write our resolver just like we have type defs in the variable. Let's write another variable const, let's call it resolvers. Again we use not backtick, sorry, this time it's curly braces, the object. So here we want to write a resolver for query. So we write query. Now in this query we need to resolve this particular query, total post. Okay, so we write total post, and at the moment we just write a function, and in this case I'm just going to write arrow function. Okay, so I just want to return the number, let's say 42. Okay, so here you can see we have returned the types, put it in a variable called type defs. This is the query type, and this query type will be resolved here in the resolver function. So both in the types or in the resolvers, we still need to make sure that we are using the right type, whether it's a query type or mutation type, we still need that. And then we will create a function in the resolver that will resolve this query. By the name of this query will be resolved by the same name function here in the resolver. Okay, so now that we have the queries and resolvers, all we need to do is create a server. That was the minimum requirement to create a GraphQL server. All right, so here, let me put that comment here. So let's create a server. Const Apollo server equals to new Apollo server, which we have imported here. Okay, so this is a function and it takes this object as an argument. So here we pass the type definition and resolvers. Okay, so the type defs comma resolvers. Okay, so this is how you create a GraphQL server. Simple as that. You have the types, you have the resolvers, you pass them to create a GraphQL server. Now let's give this a try, just like we did with our Express server here. Come all the way down, we listen to the port, so we can grab this code, okay, and come back here and paste here. Now we can say GraphQL server is ready at the localhost 8000. All right, so this is all happening in the GraphQL server.js. So we need to make sure that when we run npm start, we will execute this file, not the server.js. So let's go to package.json, and previously we had server.js. Now let's use GraphQL server.js. We'll come back to it later and continue to use server.js, but for now, to give this a try, we will use a GraphQL server.js. So when we run npm start, this file will get executed. Okay, so let's give this a try. Make sure your server is running. Reference app. Okay, so that's one more thing we need to fix. So you can see here, we just copy paste that code. Now we don't have the app, instead we have Apollo server. Let's paste that here. All right, beautiful. Okay, so make sure your server is running. You can see here GraphQL server is ready at this URL. Okay, let's give that a try. Localhost 8000. Okay, so you can see here we got the GraphQL playground as well. Beautiful. Now we can give this a try. We have just one query, and you can also check out the docs. Okay, so you can see here query that we have is just one. It's a total post. It returns the integer value. If you click here, okay, so it returns the integer type, nothing else. Okay, let's give that a try. Query total post. Okay, hit this play button, and in return you get the total post 42. That's what our resolver is returning here. Okay, so this is the very basic GraphQL server which we have created in this lecture. In the next lecture, we will look into how we can integrate this GraphQL server in the existing Express server. In the previous lecture, you saw how we could create a GraphQL server using Apollo server, and in the lecture before that, you saw how we could create our Express server. Now, in this lecture, we're going to basically combine both of them. So we want to continue using our Express server. There are a lot of benefits of using Express server. Maybe you already have the existing server, or you might want to utilize some REST features in your application later, which is obviously a great idea. So this is the approach we're going to take. So we're going to continue with our Express server, but we will bring in Apollo server as well. So our application is going to be pretty much functioning as GraphQL server, but if in case we need to utilize some REST endpoints, we can definitely do that as well. All right, so let's see how we can convert this to a GraphQL server. So basically we can, the first thing we can do is bring in the Apollo server. Right, so here from this GraphQL server.js, let's copy this code and go to server and just put down here. Okay, now we have Express as well as Apollo server. Now the next thing we want to do is bring in the HTTP, which is a core Node.js module. All right, so const HTTP equals to require HTTP. Okay, so this is a package comes with Node.js, so you don't have to install it. So this gives us the ability to create a server. All right, so let's come down here. We have the Express server. Before we do anything here with the REST endpoints, let's make sure we have the type defs and resolvers as well from this file. We need these type definition and resolvers, which is the basic requirement to create Apollo server. And this is how we create the Apollo server, right? So pretty much everything we can copy. So copy everything from here, type defs, resolvers, and Apollo server, and come here and paste it right here. Not much so far. Now what we're going to do is we're going to apply this Express app as a middleware to our Apollo server. Okay, so let me write a bit of a comment here. Apply middleware. This is the method we're going to use. This method connects Apollo server to a specific HTTP framework such as Express. This is the one we're using now, but you could be using some other JavaScript framework, for example Koa or the Sails. There are quite a lot of frameworks out there. Express is the most popular one. Obviously you can apply any of these existing server like Express as a middleware to your Apollo server. So let's see how that works. So Apollo server dot apply middleware, and we pass here so app, right, which is the app, the same name. Okay, now if you have the same key and value, you don't actually need to write it like so, you can just leave it like that. Okay, so that's how you apply the server as middleware to your Apollo server. Now once we do that, we can utilize this HTTP that we imported from core Node.js. So const, let's call it HTTP server. HTTP server equals to HTTP, and this package, this module gives us a method called create server. Create server, and you just pass your server. In our case, that is Express app here. So what's happening here is we utilize this core Node.js module called HTTP, and this gives us this method called create server that will allow us to create a server, right? So we pass the Express server to this create server method. So we have the Express server, and this Express server itself is also applied to the GraphQL server using this apply middleware. Okay, so that is pretty much it. Now we have the HTTP server that can be used as a REST API as well as GraphQL server. Okay, so here down here we can slightly modify. We can have one more console log. This is serving the REST endpoint, right? Now we can have one more console log. Let's copy this and paste here. Now when you use this apply middleware method, by default GraphQL will be served in the endpoint of /GraphQL by default. Okay, so here console log, let's say GraphQL server is ready at localhost 8000, and we can also get the GraphQL path. So here we have Apollo server. Let's use that here, $ curly brace Apollo server dot GraphQL path. All right, so this gives us the path where our GraphQL server is accessible. Now by default it should be available in /GraphQL. So now we have Express server, which is basically a GraphQL server, but we can still utilize REST features if we need to. Okay, beautiful. Now let's have a look in our console. We're not seeing the GraphQL. We have two console log, but we're not seeing that. That's because here in the package.json we still have the GraphQL server. Let's get rid of that. Okay, it's very important. If you don't do it, you won't see much happening here. Okay, now let's stop this, start one more time. Okay, Apollo Server Express. Okay, so that is one thing we missed here. So what we did here, let me close this. So previously here we just created the server, Apollo server, so this package worked perfectly fine, but now we're trying to use it with Express. Okay, and for that there is another package which is called Apollo Server Express. As you can see here, even these errors, they are quite helpful sometimes, in fact most of the time. So you can see here we need to use Apollo Server Express instead, not just Apollo Server. So let's quickly fix this. npm install apollo-server-express. Okay, so while it's happening, let's come back here and let's change this from Apollo Server to Apollo Server Express. Okay, that is the one we need, and everything else can stay as it is. All right, let's come back here, let's restart. Okay, now you can see we have two console log. One is the one we already had before, server is ready on this URL, and then GraphQL server is ready on this localhost 8000/GraphQL, which is the path where GraphQL is served, as you can see here. Okay, let's give this a try. Now this should continue to work. Let me give a refresh. Now we don't see anything here because this is currently now in GraphQL. Okay, we still have rest. Perfect. Let's try GraphQL. Beautiful. Now we have one query, total post. This gives us the integer. Let's try, and we get the output 42. Perfect, right? So you saw how we could create HTTP server, you saw how we could create GraphQL server, and in this lecture you saw how we can integrate GraphQL to any existing Express server. I'll make this source code available for each lecture, so if you come across any issues, make sure to check out the source code, make sure you have this package installed, and make sure your package.json have now node-mon server.js, not GraphQL server. Instead, I'm just going to get rid of this one. We're not going to use it. Perfect. I'll see you in the next lecture. In the previous lecture, we saw how we could build our GraphQL server with Express. Now, as you can see, we have type definition and resolvers, everything here in this single file, which is not practical in real world. As our application grow, we need to separate these type definitions, resolvers to their own folder and files, right? So let's go ahead and implement that. To be able to use multiple types, we need to somehow merge them and use here in this Apollo server here. So for that, we can utilize a package. Let me quickly take you there. Let's search for merge GraphQL schemas. All right, so npm.js, we're going to utilize this package. That makes it really easy to merge multiple type defs as well as resolvers. Okay, as you can see, it's quite a popular package as well. So let's install this. Come back here. Let's stop the server and let's install this one. So while it's happening, let's go back to our project. And first thing we want to do is we want to extract it away to a different folder, right? So let's go ahead and create a new file here in this server. Let's create a new folder. Let's call it type defs. All right, and here let's create a file. Let's call it post.js. Put all our types here, schemas, types, whichever name you like to call it. So here, first thing we want to do is bring in GraphQL. So const GraphQL equals to require this Apollo Server Express. Apollo Server Express. and we're going to export the GraphQL query that we're going to write here. So let's use module.exports GraphQL backticks. All right, so we're going to write our query here, which is going to be exactly same. In fact, we can even copy this. Type query total post. Okay, so this is basically what we did here. Is we just cut this type defs from here. So cut it out from server.js, because now we have this here in the type defs folder, and we are doing model export, exporting this query. Now all we need to do is import this query in server.js and use, right? That's quite simple. However, later on, we're not going to just have one type defs called post, we're going to have many. So we need a way to merge all those type defs and pass to the Apollo server here. And that is the reason why we install that package here called merge GraphQL schemas, right? So let's use that here in the server. So let me put it right here. Const file loader with capital L. So file loader and merge types. And I'm pretty sure you can get this information from the official npm docs. Unfortunately, they didn't have it. Okay, that's right. We just write here. So file loader and merge types we can bring in from this package. Require merge GraphQL schemas. All right, now we're going to utilize them. So right here, resolver, we had the type defs here before. Okay, type defs, let's write here. So const type defs, we can still create that, utilize this variable, because that is the one we're passing here. So we can still use that. Now all we need to do is, instead of bringing this individual file, we're going to bring in all the files that belongs to this directory, file type defs, this folder. Any files within this folder, we want to bring them in, merge, and use here in the Apollo server. So const type defs equals to merge types. All right, merge types. So here we're going to merge the types definitions here using the file loader. So file loader. Now this file loader requires the path from which folder we want to load all these files, right? So file loader, this is a function, we just pass the path name. That means we need to bring in the path model as well, module, just like HTTP or the core Node.js module, we also need path. Require path, right? So down here, to load the file, we use path dot join method. Now here we first need to go to the root directory, so _dir name, so root directory, and then comma, and give the folder name, so / type defs. So go to the root directory, go to the type defs folder, load all those files, merge them, and make it available in this type defs variable. And we're going to simply use that here in the Apollo server, which we already have, so we don't need to do anything here. Now we can continue to add more type definitions here, create more files, they will be auto loaded. That's great. Let's quickly give this a try. Let's start the server, npm start, to make sure we don't have any errors. Okay, perfect, still works. Now to give this a try, why don't we try to add one more type definition here. Let's create one more. Let's create a file, let's call it auth.js. So here, just like here in the post, we need this GraphQL. So why don't we actually copy everything here, put here. Okay, so module export, let's query this time, let's query for me. Okay, so this is the query type, me, and this should return a string. Okay, so previously we tried integer, let's try string. So we got this new type definition, and which has the query by the name of me, which should return a string. We still need the resolver, just like we have here in the post. Post has this total post, and by the same name we have a resolver that will resolve this query. So we need something similar for the me as well. Otherwise, just by writing a query, nothing happens. But that's all right. We can go to server.js and add one more resolver here. So right below here, let's say me, that is our query, the name of the query, and it will return, again, I'm going to use arrow function here, and let me just return a string this time, because this one requires a string. So let me return Ryan. Simple as that. Okay, so let's give this a try, and in the next lecture we're going to do the same with resolvers. We're going to move it to a different folder and load dynamically like so. Okay, let's try me query. So here, instead of total post, let me actually give it a refresh. Okay, me, all right, and we get the response Ryan. Beautiful. Okay, so we created two queries so far. One returns integer, another returns a string. Beautiful. In the next lecture we're going to load resolvers dynamically, just like we did with type definitions. In the previous lecture we learned how to merge types and use here in the Apollo server. Now we're going to do same with the resolvers. Okay, so it's going to be pretty same. This package provides us another method called merge resolvers. Okay, so we can use that. First, let's write that here. So const resolvers equals to merge resolvers. Now let's make sure we import this here, merge types as well as merge resolvers. All right, so merge resolvers, and here we're going to again use the file loader. We need to pass the path. So let's begin with the directory name. So it means the root directory, which is the server folder here, comma, we give the folder name that's going to be resolvers, which we haven't created yet, which we're going to create now very soon. Okay, so that's where, just like we did with type defs, we're going to create multiple resolver files here, and they will be dynamically loaded here. All right, so we're going to cut this out and put in the file here. So let's create a new folder first called resolvers, and here I'm going to use the same naming convention as with the type definition. So we need to create two resolvers. One is auth, one is post. Auth.js, okay, and another one is post. Post.js. Okay. So what we're going to write here is basically whatever we have already written in the server.js. So this is what we're going to now move to this directory. So cut from here and paste here. So resolvers, first let's go to post and let's paste here. We also need GraphQL, just like we have imported in the definition, type definition. Let's copy this one and back to resolvers post, let's put here. All right, this is a post resolver, so we're just going to keep this total post now. Obviously there will be many more queries and mutations and all that here, but at the moment we just have one very simple query. Okay, so whenever we get this query, this will resolve, this function will resolve to this integer value, dead simple. Now let's copy this and paste here in the auth as well. So in the auth it's going to be me query, and it will return a string value of Ryan. So we've got the resolvers here, they looks good, but we need to export so that we can import or require in server.js and use, right? So just like we did with type definition, you can see we have used module.exports. We need to use the same way. here. So instead of writing this variable resolvers, we're just going to use module.export. Okay, we are exporting the query resolver here, and let's go to post as well, and let's use module.exports and this export this query total post. Okay, now everything should work exactly the way it was working before. We just moved these resolvers to their respected files, and here in the server we are using the merge resolvers. The result is here in this variable, and that is used in the server. Pretty similar to what we did with types. Okay, so let's give this a try, make sure it is working. Okay, so we have an error here. I realized I missed the path.join. That method I missed, so let's make sure I use that. Our directory name and resolvers, let me wrap it inside a parenthesis and use path.join. Okay, so we have the file loader which ends here, and then inside there we have path.join, and we give this path. Okay, perfect. Let's try now. Okay, now I can query me as well as total post. Beautiful. Okay, so we have moved type definitions as well as resolvers to their own files and folders, and we are loading dynamically using merge GraphQL schemas. Okay, beautiful. Before I end this lesson, I would like to cover one more thing here. Here in the resolver, for example, let's go to auth. At the moment we have only one query, and it is a dead simple query, because most of the time you will not have such a simple operation to do. You will have a large function, multiple lines, quite big. Okay, and then you need another query, then you will separate that by comma and then write some other query, something like that, quite long and big query, and then again you have another query resolver and then more. So all of them must be separated by comma. So over time it gets quite confusing, and missing one comma will lead to many errors. It just goes a bit out of control. I don't really like this approach. So what I'm going to do is I would like to extract this to a separate function here, so that it is nice and easy and it is pretty clean. So what I'm going to do is here, whenever I have the me query, I will use the me function. Okay, now because the name and values are same, I don't need to do that. I'll just leave it like so. So instead of writing the entire function, the query resolver here, I'm going to write here. Okay, so const me equals to, just paste that in here. Let me just paste here. Okay, simple as that. It is exactly like writing like so, because we have the name and value they are same, we just leave it like so. Now later you might have 10 different resolvers like so. Okay, but that's all right. All you have to do is add here another resolver. This could be quite a big function here, doesn't matter, it's quite clean and easy to read. Okay, so that's what we're going to do here. Let me make sure I remove the quote. This is anonymous function, and this is a variable which has the value of a function. So whenever we get the me query, we executing this function, and that will return this string. Now let's do the same with post as well. So instead of writing everything here, I'm going to extract to a function here, const total post. We keep the same name, and it will be a function that will return this integer value. Okay, now later you can add more resolvers here. All you have to do is write your resolver function here and then add it here by comma separation, and that is it. Okay, now one more time, let's give it a try, make sure we don't have any errors. Okay, all right, so looks like we've got some typos there. Total post, in the resolver, in the type definition we have total posts. Okay, so it has to be plural. So sometimes such small typos can give you headaches, but yeah, don't stress and just try to go through the error message, and you should be most likely be able to solve on your own. Right, so let's fix that up. Let's make sure we have the same name with S here in the result row as well. Total posts, total post. Perfect. Okay, that looks good. Let's try total post and me query. Beautiful. All right, so we have dead simple, very small function here, but you saw how we have been structuring our application. We are dynamically loading type definitions, resolvers, and here in the files we have very good structure. Now we can write more and more functions here, and we just add here by the comma separation, and we are all good. It is very nice and easy to read as well. So let's continue. We have done quite a lot of groundwork with our GraphQL server setup. Now let's move on and connect our server to database. So we can use Mongo Atlas, or you can even use your own local MongoDB installation, and then we will go from there. In this lecture, we're going to connect our server to MongoDB. Okay, so there are two options. One option is you can use an online service called Mongo Atlas, and another option is use your own local installation of MongoDB. Right, so in this lecture I will cover how you can use Mongo Atlas, which is easy to get started. But if you have already installed MongoDB in your local computer, then you can check out my next lecture where I will show you how you can connect locally. Right, so let's try using Mongo Atlas. So one limitation of Mongo Atlas is that you can use only one connection as a free service. If you want to connect more than one, then you need to pay. So unless you are ready to pay, you can create a new Gmail account and then use that new Gmail account to sign up to Mongo Atlas so that you get at least one free connection. And that is what I'm going to do here. Okay, so Mongo Atlas, and let's come down here, and this gets a little bit tricky, so probably you should click here on the free option here, sign up. All right, this is get started. Okay, let's try this. So I have created a new Gmail account that is GraphQL React Node at gmail.com. Ryan Dingell, let's say okay, so we're going to take the free one. Let's take the default option here. So AWS, North America, US East 1. Let's just leave everything as it is. We get 512 MB with free sandbox account. Everything is fine. Let's just change the cluster name. Let's call it GraphQL React Node. Create. So it will take about 1 to 3 minutes. So I'll get back to you once it is done. All right, so it is done. Now let's go to network access, and we need to whitelist an IP address. So let's allow access from anywhere. Let's take this option and whitelist entry. So that means you can connect from anywhere, from any IP address from any computer. So let's click confirm. So it will allow all the IP address including your current IP. So that looks good. While it's happening, let's also go to database access and let's create a database user. Okay, let's give it a name, Ryan. Password, let's auto generate a secure password. Let's click so. Let's copy this and let's put it somewhere, so we need to use it very soon. Let me paste here temporarily. Okay, and read and write access, so that is fine. Let's click add user. Perfect. So we got the database user and we have network access as well, which is still pending. While that's happening, let's continue here. Let's go to data lake, sorry, not that one, all the way on top, clusters. Let's click here. So what we want to do is we want to now connect. We want to get this string. So let's click connect, and we have a couple of options here. The one we want to use is connect to your application. Okay, let's click that. Okay, so this is the connection string we have, so this is the one we're going to use, and we just need to replace the password with the one we got earlier. So let's copy this entire string. Let's copy that, go back to our project, and let's actually paste here. Let's paste here. So all we want to do is replace this with our actual password. Let's copy that, let's get rid of this and paste that here. Okay, so that's our password. That is all. We don't need to change anything else. Let's copy this and let's go to env file. That's where we want to create one more environment variable. Let's call it database cloud. I'm going to call it, and I'm just pasting here. Okay, so we have a database cloud string which will allow us to connect our application to the MongoDB in the cloud. Let's also make sure, let's close this, and let's make sure we have the network access active. Perfect. All right, now we can continue working in our server. Let's connect our server to MongoDB. For that, first thing we need to do is install mongoose. So we will be using mongoose to interact with our MongoDB. Instead of writing our raw MongoDB queries, using mongoose makes our life a lot easier. All right, so let's install that using this npm command, npm install mongoose. All right, so it has been installed. Now let's go back to our server here. Let me close this file. Okay, let's go to server, and here we want to connect to MongoDB. So the first thing we want to do is require mongoose. So probably we should do somewhere here. Const mongoose equals to require mongoose, and then here let's add that here. Let's write db, so const db equals to async. We're going to use async await. So we're going to create this function, and we use the async keyword to make it asynchronous. All right, so we're going to first try to connect. If we get an error, we will catch the error, and we will console log the error so that it will help us debug. Right, so to connect to MongoDB, we will await mongoose.connect. So mongoose gives us this connect method, and we can actually put it in a variable. Const success equals to, we wait for the mongoose connection. Now this mongoose connect method requires a couple of arguments. So the first argument is the URL. Okay, so it requires URL where you want to connect. Now in our case, we have that here in the env file by the name of database cloud. Right, so we're going to use this, and we have access to the .env variables using process.env dot the name of the variable. Right, so that's the first argument, the URL string. Second argument is some configuration options. All right, so when you run your server, you will get a couple of decryption warnings. To get rid of them, we're going to use a couple of these options as suggested by the official docs of Mongoose. Right? So use new URL parser true, use unified topology true. By the way, if you find it difficult to type, you might even make some typos, feel free to check out the source code. I will make it available with this lecture. All right, so use create index true and use find and modify false. Okay, so we pass these configuration options to avoid the decryption warnings. Now when we try to connect, if it is successful, we should see the success response. So we can console log, let's just write db connected. So if it is successful, if we catch any error, we will console log that error. Let me just write here db connection error. This variable has this asynchronous function that will connect to Mongoose, but we also need to make sure that we execute this function, otherwise this connection will never happen. So execute database connection, and for that all you have to do is invoke this db function. All right, now if we were able to successfully connect to this URL, we should see a db connected printed in our server console. Let's try it. Let's make sure to run the server npm start, and you saw here db connected, which is great. It means that we have successfully connected our server to MongoDB Atlas. Now in the next lecture, I will also show you how you can use the local install of MongoDB. If you have installed locally in your computer, then I will show you how you can connect locally as well. In the previous lecture, I showed you how you could use Mongo Atlas to connect our application to the MongoDB in the cloud. However, if you have it installed locally, that is much better, especially when you're developing. Okay, because Mongo Atlas, when you are using the sandbox mode, it is a bit slow as well. Now, when you have it locally installed, obviously you can easily access the MongoDB using a software called Robo3T, which I will show you how you can install that. And then it will be much easier to edit some data as well if you need to. You can visually see your MongoDB database and all that stuff. All right, so let me close this and let's go do a bit of a Googling here. Let's search MongoDB install. So manual installation, let's click here, Mongo docs. Okay, so you get a couple of options here. So based on your operating system, whether you are on Mac or Windows here. So if you are on Windows, you can follow the instruction here. Okay, so first thing you want to do is download MongoDB from here using this link, and then follow the instructions step by step, as you can see here. All right, now if you are on Mac, probably the easiest option is to use brew. So you can install homebrew and just run this command and it will install. Okay, so once you have MongoDB installed locally, you want to also use this another graphical user interface software for MongoDB called Robo3T. All right, so this will allow you to visually see your MongoDB. Makes it really easy to visually see, edit, modify, delete, all that stuff. It's free to download, so you can click here, download, and install as you would install any software in your computer. Okay, so once you do all that, once you install MongoDB, once you have this Robo 3D, you should be able to connect to MongoDB locally. Now you can also try opening a new terminal window here, Command T. I'm going to open a new window here, side by side, and I can run Mongo. Okay, so immediately you see I'm in the Mongo shell. I can type show DBs. I have heaps of existing database as well. All right, so let me just get out of here, exit. So that means I have MongoDB installed locally, and I can connect my application easily because I have it installed. So the first thing I want to do, and you can also do it, so go to .env and let's create a new environment variable database. Let's just call it database, and you can connect to your local MongoDB connection. So let's say MongoDB : //localhost : 27017 / give the name, whichever name you want to give. So for this project, let's say GraphQL React Node. All right, and that is all we need to do. Now next time when you restart your server, it will automatically create this database. So to give this a try, let me first open Robo 3D. Okay, so let me click connect, and you will see I have a lot of existing projects here. Now let me see, I don't see my new project here, right? So you can see the GraphQL React node is not there, not yet. Now let's run our server npm. Actually, before I do that, let me go back to my project. Now that I have this database environment variable, I can use that here in the server.js. Instead of using database cloud, I'm just going to use database. Okay, and then I will run npm start. Now again, even this time you can see db connected, which means now I'm using the local install of MongoDB. All right, so if I create some new post in database, that will be saved here locally in my MongoDB here, not in the cloud. So it's totally up to you. It doesn't matter whichever you decide to choose. You can continue with the cloud, or you can use local installation if you have. Either way will be good, but at the end, if we deploy this application to Heroku, most likely that we will use database cloud so that we can use the existing database in the Mongo Atlas. But nevertheless, whichever you use for the development of this application, it will be perfectly fine. Now that we have database connection also done, we are pretty much ready to start writing our awesome GraphQL real-time project. But before we do that and start saving the actual post in the database, we will be just playing around a bit, saving the post in the memory, not in the database, just to make ourselves a bit more comfortable before we actually start saving in the database. So next few lectures, we will give that a try, and then we will be going full on to build this awesome application as we continue to learn almost everything you want to know about GraphQL. So far we have done pretty good job in terms of setting up our server. So we have our type definitions, we have resolvers, we have database connection as well. But before we start saving anything in the database, let's make ourselves a bit more comfortable with writing queries and mutation. At the moment, all we have done is written two very simple queries. One returns integer value and another returns string value, which is not very useful in real world. So let's say, what if we need to return array of posts? Okay, so post that would have a title, ID, description, and so on. So let's see how we can do that. For that, what we're going to do is at the moment we don't have anything saved in the database, so let's hard code. Let's just write a couple of posts here, and then we will see how we can query those posts and even add more posts using mutations before we actually move to saving in the database and so on. Okay, so here in the server, in the root folder, let's create a new file. Let's call it temporary. You can delete this file later. Okay, so here I'm going to create an array of posts. Const post, it's going to be an array, and let's create few posts here. So post would have title, let's say 1. Oh, sorry, ID is 1, and title, let's say first post. Description, let's say first post description. All right, and let's copy, comma, paste here, and let's change this to 2. Second post. Okay, so we've got array of posts here. Now let's export so that we can use in our resolvers here. So module dot exports, and we want to export posts. Okay, so that's good. Now let's go to resolvers post, and at the moment you can see here we are returning the hard-coded number as total post. Instead of doing that, let's bring in these this post array from here. So let's import const post equals to require one step up temp. So we require post, and instead of hard coding this value, we can send the post length, because this is an array, and we can use a length method on array to get the length. Post.length. Okay, so that should give us 2, because we have 2 posts here. Okay, so let's give this a try. Make sure your server is running, and then let's query total posts. Total posts, post.length. Sorry, that's typo there. Post.length. Right, let's try, and we get 2. That's all we have here. Okay, so that's perfect. Nothing has been changed. We just use the post length instead of hard-coded value. Okay, so that's fine. Now let's move on to the type definition. So at the moment, this total post query is returning a single value, integer value, right? But now we want to return array of posts. So that means we need a post type here, because in GraphQL, for everything you do, it is based on type. So you want to do anything with the post, you need to first write the post type, and that type can be used to query and even for performing mutations, which we will see very soon. So let's write our post query here. Type post. Okay, so this post, as you can see here in the temp, post will have title, ID, and description. So let's write that. ID. Now it's going to be ID type. Now this ID type comes with GraphQL itself. Okay, so ID will be the type of ID, and it shouldn't be null. So you give the exclamation mark if you want to make sure that it is always there when you are returning post. It shouldn't be null. Okay, so that's ID. Title is going to be a string type, and description is going to be string type as well, and it shouldn't be null. Okay, so that's perfect. We have the type definition here. We have defined the type. Now we can return all posts, right? For example, our user or our front-end developers, they would probably want to get all the posts. So at the moment we have only this query total post, but let's say they want to query all posts, right? So no problem. If we want to perform all post query, first thing we want to do is write down the query here. So the query, in fact, let's put it below, right? Let's put it down. At the moment we have only one type, but later we're going to have many types, so it's always good to put them on top, and our queries put it down here. Okay, now if you are new to GraphQL, it can get sometimes confusing why we're writing this post type and we still need to write query type, but that's how it works. Okay, because total post is the type of integer, so we didn't have to write anything like that, but now that we are trying to return array of posts and each post will be this object type, we have to first write the type. Okay, so that's what we're doing here. So let's say we want to be able to query all posts. Okay, so when we query all posts, what type it should return? It's not going to be integer type, it's not going to be string type, instead it's going to be this type. It has ID, title, and description, so that means it is going to be post type, right? So that's what we're writing here, not integer, not string, but the post type. So that is the reason we wrote this type. Now it's not going to be just post, it's going to be array of posts, right? And that's easy. All we have to do is put it inside an array, and you can also add the exclamation mark if you want to make sure it is not null. All right, so previously we had just one query, now we have another query called all posts, which will return the post type. Unlike integer or string, it is returning post type, and this is the post type. Okay, so that's perfect. We have the query, but just writing query is not enough. We need a resolver to resolve this query, right? So that has to be with the same name. All right, so let's write all posts resolver here. Let's go to resolvers, post, and here let's write that const all posts. And what we're going to return here, it's going to be pretty easy, because all we have to do is return this posts array that we are importing from the temp. All we have to do is return this post. All right, so here in the resolver, when we get a query for all posts, all we want to do is return posts. Simple as that. Now I'm using arrow function, and this is just one statement, so we didn't even need to use return keyword. I can just write posts. Okay, now just writing this function here is not enough, because the way we have structured our application and our resolvers, this file, we need to make sure that we add here. So all posts. Okay, so we have two queries now. Total post will return the length, all post will return the array of post itself. Okay, and which is the post type, and it will have ID, title, and description. Beautiful. Now let's give this a try. Now you should see the docs updated. You can see here, actually it's not here. Let's refresh. Now we have all post as well, and it returns the post type, as you can see here. So if you click, you can see this post type has the ID, title, and description. So you can query any of these fields. You might want to query only title, description, ID, or all of them. You can query all those. Okay, so let's try query. Let's query all posts. Now just writing this is not enough. Previously it was enough, because previously we were just returning a scalar value that is either a string or integer, but now it is the post type, which is an object. It's not going to work. Okay, so fields must have a selection of sub fields. All right, so we need to select the post type, whatever is available. In the post type we have ID, title, and description available. If you want only ID, that is totally fine. You see we got two posts, and both posts ID we have. Now if you want title as well, you do that, you get the title. If you want description as well, you get description as well. So this is another beauty of GraphQL. You select what data you want. For sometimes the post might have a huge collection, a lot of properties, and you might not want all of them. That's totally fine. You just query and get whatever data you want. Okay, so this is also called a declarative fetching. So you do not overfetch, you do not underfetch, you fetch whatever data you need. Anyways, this is great. Now we have added one more queries, and you saw how we could return the array of post as well. Okay, so this is the query, this is the post type, and this is the resolver that returned all posts. In the previous lecture, you saw how we could write our queries to return the array of posts. Now in this lecture, we're going to see how we can create posts. Now if you remember, I talked about it earlier. In GraphQL, whenever you want to get the data, you send a query, but whenever you want to update the data, update or delete, then you use mutation. They look pretty similar, but that is the naming convention. So if you are used to REST API, in REST API, when you need some data, you send a GET request. For everything else, you use a POST, PUT, and DELETE request to update or delete the data in the server, right? So it's similar in GraphQL, but in GraphQL, for anything to get any data, we use query. For everything else, we use mutation. So that means we need to write a mutation now, because we want to create a post. So creating, updating, deleting, for doing that sort of things, we're going to use mutation type. Okay, so here, right here, in our type definition, here in the post, let's write our mutation type. So let's write a mutation type here, right below the query type mutation with capital M. All right, and you can also leave a comment here in your schema here if you want. You can use hash and then let's say mutations. Okay, this way you can write comments as well if you want to. Okay, so here what we're going to do is we're going to write a mutation to create a new post. Okay, so let's call it new post. That's the name of our mutation type. Okay, now it requires some argument, because to create a new post, obviously we need the post title and description, right? ID we can auto generate, but we need at least title and description to create a new post. So that means we need some arguments, and we can accept the arguments here. So new post, it's a mutation which takes an argument of title, which is going to be the type of string, and it shouldn't be null. All right, and then comma description, it is also going to be a type of string. It shouldn't be null. All right, so this is how we can take arguments, and we also define the types, what type of argument these are going to be. Both of them are going to be string type for now. All right, so that is it. Now we also going to return, once we perform the mutation, we return something, right? So we return this newly created post. So we need to write here, just like previously we had integer type, we are returning integer. A string type, we were returning a single string. Before on all posts, we were returning array of posts. So in a similar way, on this mutation type, once we create a new post, we want to return a post, right? So we just write post, and it shouldn't be null. Okay, so the only difference here you can see this time, when we were querying the all post, we were sending array of posts, but on mutation we are creating a single post, and that is the one we are returning. So it is just a single post. All right, so there we have our very first mutation. Now if you're thinking, what if we have many more arguments to take? At the moment we have only 2, but what if you have 10 arguments, right? A new post can have title, description, author name, and so on. It can have many categories and so on. So writing all these arguments here like so is not practical. Okay, and for that we have another type called input type. We can create a custom input type and we can use that, but we will try that later. At the moment, just let's keep it simple. So here we have our very first mutation by the name of new post. It requires title and description, and it will return our single post. All right, so let's go ahead and write this function in our resolver. So just like queries, writing a mutation type itself will not do anything unless we have a resolver function to resolve this mutation, right? So let's create this resolver as well. So resolvers post, we're going to create a new resolver, mutation, and these are queries. So let me just write queries. Okay, so mutation type is going to be new post. All right, now just like we export queries, this time we need to export as mutation because this is a mutation type, right? So after this query, comma, and write mutation, and our mutation type is new post. This is very important. If you forget to add here in the module exports, then you might get some errors and you might get confused what to do, right? So make sure you have, anytime you have added queries or mutation, make sure to add here in this module.exports object. So let's write our mutation here. New post. To create a new post, first of all, we need to generate the ID, right? So at the moment we have 2 posts, so the next post would have the ID of 3. Okay, so we can access this post array and just increment the length and use that as ID. So basically we want to create a new post object and push to this posts array, right? So let's create all new post object, and then later we will push to this post array and we're done, right? So const post, so ID, it requires ID, and we're going to generate the ID using post.length, and we just increment to whatever length we already have. So at the moment we have 2, so the next post will have ID of 3 and then 4 and so on. So that's fine. Now we need to take the arguments, right? So we have written here in our type definition, new post, whenever you want to create, you send the arguments title and description, right? So we can access those arguments here. Whenever you write a resolver, they get a couple of arguments. So first one is parent. People also write just underscore and use comma, whichever you like. I like to write parent. Now I will explain what parent does very soon. So first argument is parent, second argument is args. Okay, so most of the time this is the one you use, arguments. And then next one is context as well, which we will cover a bit later. At the moment, these are the 2 must-have arguments. So most of the time you don't even use the parent, so people usually use just underscore. But what parent means is, parent basically means parent mutation type. So in this case, here in the type definition, this new post, this is the parent. All right, so that's parent, and the second argument is args. We get all the arguments. So in this case, the title and description, these are available here in the args object. So here we need the title from the args, so that's going to be args.title, and then description, it's going to be args.description, and you can also console log the args. Okay, console log, we can write args so that we can see in the console as well. All right, so we have the new post, we have the title, ID, and description. In fact, this should be post length +1. Okay, so this new post we need to push to the posts array. All right, so here push new post object to posts array. Okay, so we can use the push method. That's quite straightforward. Post.push, and we want to push this post. Okay, that's perfect. Now we also need to make sure that we return. As you can see in our type definition, when we create a new post based on these arguments, we need to return a new post, which is the post type, that should contain ID, title, and description. But that's easy here because we already have that post here. So all we need to do is return this post. All right, so return post. That is all we need to do. Now let's give this a try. So this is our mutation type. We have here written in our type definition, as well as we have this new post resolver here as well, that resolves by creating a new post, pushing to the post array, and returning the post type. Perfect. Let's give this a try. So let me give a refresh. Here in the docs we should see now we have the new post mutation, which returns the post type, and it takes argument of title and description. So let's give that a try. Let's get rid of that, write mutation. So the name of the mutation is new post. Okay, it takes title as an argument, so title, colon, and double quotes. Make sure to use double quotes because single quote doesn't work here. Okay, so title, third post, comma is not mandatory. You can not use comma, that's fine. Description, double quotes, let's say third post description, and you select the fields that we want. Okay, so the curly brace here. So when you create a new field, you get the post in return, which will contain ID, title, and description. So we can get these values in return as well. So let's give this a try. Let's hit the play button, and definitely we get the response, and the response contains the new post. Okay, so this is something different. If you are used to a REST API, when you perform queries or mutation, the same name is returned here in the data as well. So you can see we get data, and you get the same name that you used to perform either query or mutation, and then you get whatever fields you ask for example ID, title, and description. Okay, now you can create many times. It is not saved in the database anyway, so we can just try. We can write whatever. You can see ID, title, and description every time. Now if we want to select only ID and title, that is also fine, no problem. Okay, perfect. Now this is how we can perform a mutation in GraphQL. Now let's have a look in the console as well. We want to see the arguments, and you can see every time we pass these arguments, they are available here in the args object. Okay, now we can further destructure here, which is not really important here. All we're trying to do is learn, and it doesn't have any benefits or anything. But if you like, you can also destructure title and description directly here. That way you don't need to keep writing arguments. You can just do it like that. Let's comment this out. Okay, so this way also you can do, no problem. Okay, it works, beautiful. Now another way would be to, let me just go back. Instead of destructuring there, you can also destructure here. Let's comment this out. Const, it's not comment, so const, you can destructure title and description out of args. All right, and that way you don't need to write args here. Okay, so this will also work. Okay, but I'm just going to stick with the previous way, which is very simple and easy to understand. So anytime you want to have a look at the code that you wrote in future, it will be much easier to understand. I guess I'll leave it like so. I'll just comment out the console. All right, so this way you learn how to create a mutation in GraphQL. In the previous lecture, you saw how we could perform a mutation. We could create a new post by passing these arguments, title and description, like so. All right, so let's go back to our type devs here. So this is how we could pass these arguments, title and description. However, when you have to pass a lot of arguments, this is not really practical. For example, if you have to create a post with title, description, categories, posted by and some other fields, it can quickly go out of control and it can get really messy. So instead, we can utilize another type that you can use with GraphQL, and that is called input type. So let's give that a try. So here, let me have a comment here, input type. So to create an input type, you don't start with type, you start with input. Okay, so input, and give it a name. Give this input type a name. Let's give it a name of post input. Post input. So as you can see here, GraphQL is all about types and resolvers. So you create a type and you create certain queries and mutations that returns the type, and you create a resolver function that resolve those mutation or query type. Okay, so at the heart of GraphQL, there are types. All right, so let's write this input type. So whenever we want to create a post, we want a title, right? So we want title that has to be a string type, and it shouldn't be empty. And let's also make sure we have description. All right, so this shouldn't be empty as well, and it's going to be string and ID as well, right? So ID is going to be the type of ID, and that should be required as well. So this is the input type. We have written the input type here. Now, instead of writing everything like so, we can get rid of all that, and let's use the post input, and it should be empty. All right, now we can give this a name. Let's call it input. This way it will be much easier when you pass these query variables to your mutation function, which you will see very soon. All right, so when you create a new mutation using the GraphQL playground here, and later using React or any other client, you will use this mutation function. And when you pass the arguments, instead of writing everything down here like we did earlier, you're going to pass the input variable, and this variable must contain this information, which is required here: ID, title, and description. So basically, this input type is required here, and you pass this as a value of input variable. Okay, so it can get a little bit confusing in the beginning, but this is really something you have to get used to it, because this is the standard way of performing mutation and passing variables to your mutations. And I just realized that we don't need the ID here, because ID will be generated here in the resolver, so we don't need that here. Let's get rid of that. Okay, so post input basically requires title and description, just like we were doing earlier, but it will be slightly different the way we pass the arguments, and we're going to see how we can do that. So let's head over to the playground here. Previously we passed everything here. Now we're going to pass the query variables. Okay, so here in the bottom you can see a couple of options here. We have the query variables option, we have the HTTP headers option, which we will explore a bit later. Okay, so let's click here. So you can click here to collapse, and you can click here, double click to open it. All right, so here we're going to pass the query variables by the name of input. If you remember here, we have given the name input, and it will require title and description. Okay, so here first we create this object, double quotes, that's really important, not single quote. Okay, so input colon curly brace, and here we're going to pass the title. So title, that's going to be passing query variables. All right, comma, let's pass description as well. This is my description. Okay, so this is the input variable we have here. We are passing the title and description. Now this is what we need to use here on the new post. So let's get rid of this. Okay, so here we are using these query variable. Okay, so you will use $ and input, all right, and then colon. This is going to be the type post input. Okay, now you can also see that information here. New post. Okay, looks like we need to restart, so let's refresh. This information will be here, so you don't need to worry. Let's look at the docs now. You can see previously we had the title and description written here, but now we have the input, which is post input. So you can click here and have a look what this post input is about here in the argument section. Just click here. So you can see here, when we send the input, it has to be the post input type, and then the post input type basically requires the title and description. All right, perfect. So here, so the input variable is going to be post input type. Okay, and this contains this information, query variables. If you hover over, you can see something's not right. Okay, so we have the syntax error, and the reason for that, at the moment, even if you try to use prettify, the code will not format because we have got an error. So the problem here is that when you are passing variables like so, you need to slightly change the way you write your mutation. So previously we were writing mutation like so, just like we were writing queries, but now it's going to be slightly different. So let me get rid of this on top and bottom. All right, so here in front of new post, let's write mutation. So this is the mutation called new post, which has the input variables that refers to this input post input, which is here title and description. All right, and then let's get rid of that. So here again we need to write new post, and then we write input here, input. So the input is going to be this variable input, $input. Okay, and here you can ask what information you want, for example post ID, title, description. Okay, and you can even use prettify. Now it works. Okay, so a slight difference here, and it can get a bit confusing when you're starting for the first time, but over time you get used to it, and we will be doing this many times in this course, and by the end of this course you will be quite a professional. So if you take a moment and try to read this function here, it will make perfect sense. So you are creating a new post mutation which requires input variable that need to fulfill the requirement of this post input type. Okay, and so that's the first step. Second step is the actual mutation, which is new post. It requires input, which is this variable which has all the value required to this input, and we just ask for the new post information, title, ID and description. So if we try now, we got the error here. Post input used in expecting type post input not empty. Okay, so make sure we have the exclamation mark there. Now this is another important concept to grasp, and it can give you a bit of a headache in the beginning, but if you think about it, there has been a slight change. So here in the resolver, previously we were getting the arguments straight away. So you can see here, previously we were getting args, so we could simply grab the args title and args description, right? But now it is slightly changed. You can see in the type definition, it is now in the input, so it will be args.input, and then you can access the title and description. Okay, so because of that we're getting the error. So it's a good time to have a look at the console log args. Let's try. Okay, let's try. We don't see anything here, but if you go to the console, you see we still get the title and description, but they are inside this input object now. So that means we have to slightly modify our resolver here. So we can either write args.input.title, args.input.description. Okay, and that should do. Let's try it. and you can see here it works. Let's try a few times. We just see the ID because we leave it same, we don't worry about changing it, but you can see here it works. Again, it is a bit more repeated code here. There are a few ways of making it look better. One would be to extract const title description from args.input, and we don't need to write input here. We don't need the args as well. We just write title and description. Okay, perfect. Let's try. It works. Now because their name and value they're same, we don't need to even write like that. We can just write like so. Okay, so this will also work. Or even better, we can use this spread operator, args.input. Okay, so this will also work. Let's get rid of the console log. Okay, let's come here, give it a try. Perfect. All right, so you saw one of the important concept in this lecture, that is using the input type. It can take some time to sink into your brain. It gets a bit confusing in the beginning, but over time you get used to it. So we have taken the input variable. It has to give us the input type, and we pass the input type using the query variable input, passing the title and description. We grab that in this new post mutation here, and then executed the new post mutation, passing the input which equals to input, which refers to the post input type. So far you learned how to create queries, mutation, you learned how to create GraphQL server, all that stuff. That is great. However, we are still in the backend. We haven't moved to the front end yet. I think it's a good time to move to front end, set up our GraphQL client with React, and slowly make our way up, see how we can make queries from our client application, and then later on we're going to implement authentication. We're going to be performing mutations, subscriptions, and everything you need to know. All right, so in this lecture, let's set up React client with GraphQL. First thing we need is to create fresh install of React application. Right, so I'm currently in the server folder. Let's go back. All right, let's go back. So we should be working inside GraphQL, cd GraphQL. We have server folder. Let's create React project. So we can use create React app. So npx create React app. Let's call it client. All right, so it has been installed. Let me get inside the folder cd client. We need to first install the necessary packages we need to set up our GraphQL client. But even before that, let me quickly take it to the official docs. It really helps to make ourselves comfortable with the docs. Right, so go to apollo.graphql.com/docs, and you can search for React client. Let's click here. You don't have to do it, but I'm just showing you in case you might need to visit documentation sometime in future. Right, so here on the left we have the menu here, get started. And by the way, you can see here Apollo Docs supports a couple of different environments, such as you can see it's for the React client. They have one for iOS as well. They have one for server and so on. So we are now in the client React. All right, so you come down here and you can see the installation instruction here. So we need to install at least these packages, so Apollo Boost and GraphQL hooks, as well as GraphQL itself. All right, so we're going to be using hooks. That makes our life much easier, and it's really easy to get started as well. So hooks are great, so we're going to use that, and we're going to use Apollo Boost. And I would like to talk a bit more about Apollo Boost before we do anything further. But first, let's install these packages. So we have total 3 packages we are installing here: Apollo Boost, at Apollo React hooks, and GraphQL. All right, so you can just click here to copy, and get inside our client folder. We are inside client folder. Let's install them. While it's installing, let's go here and let's try to understand a bit more about Apollo Boost. Okay, so these are self-explanatory. These are hooks. We can use hooks to perform queries and mutations, so that's great. We need GraphQL as well, that's perfect. But Apollo Boost contains more than one package, right? So let me take you to npm Apollo boost. Sorry. So let me come all the way down here. Okay, so what's in Apollo Boost? So Apollo Boost includes some packages that are essential to develop the Apollo client. So when it comes to Apollo Boost, this is a combination of all these packages. So you can see here, Apollo client, Apollo cache in memory, Apollo link HTTP, and all these GraphQL tag and so on. So we have two options here. One is to just install Apollo Boost and we're done. We don't have to install all of them individually, or we can install all of these individually and don't worry about Apollo Boost. Okay, so either way is fine. However, let's get started with Apollo Boost. It's really easy to get started instead of individually installing all these packages. So now that you know what Apollo Boost is and what it includes, let's go ahead and get started. All right, so we are following the docs here. We install all these packages and we can create a client like so. We can import Apollo client from Apollo Boost. If we install these packages separately, then we would bring Apollo client, we would import from this package. But now that everything comes into this Apollo Boost, we can just import like so, and then we can create a client like so. Once we have the client, we can make a query like so. So let's go back to our project. All right, so we are inside client folder. Let's run npm start to start our application. Okay, so we have React application running here, and here we have client and server. Let's go to client, and the first thing I would like to do is remove a couple of files that we're not going to use in this project. Right, so app.css, let's get rid of that. Let's remove test as well. We're not going to write in test. Let's leave index.css, but let's get rid of everything. Let's get rid of logo. Let's get rid of service workers. Let's get rid of setup tests. And let's go to index.js here, and let's get rid of service worker and this comment. Okay, let's also get rid of this here, and let's get rid of, actually that's all we need. All right, perfect. So our application at the moment is just one component, app component, which is being rendered using the react-dom.render method. It is being rendered in the div with an ID of root, which is right here in the public folder, index.html. We have the body tag has the div with the ID of root, and this is where our React application will be rendered. Okay, so at the moment it is just one component. Okay, so let's go have a look in this app component and see what we have here. Okay, so we have logo. Let's get rid of that because we already deleted the file. App.css is also no longer there, so let's get rid of that. And we have this div. Now I'm going to get rid of the entire div. Okay, and maybe I'll just write something like, let's say hello. Okay, let's have a look. Perfect, we got hello. That's great. Before I end this lesson, I would like to quickly utilize a CSS library that we're going to use in this course, and that is Bootstrap material. All right, you can use some complicated CSS frameworks for React, component based frameworks like Material UI and Design. You can go crazy with styling, but in this course I'd just like to focus more on the other functionalities than styling. So I'm just going to utilize Bootstrap material, which is dead simple. It's really easy. It's just a basic bootstrap class name you can use, and you get a nice material look. All right, so this is the one I'm going to use, and I encourage you to use the same thing at least while going through this course. It's beautiful. All right, so let's grab the CSS, okay, and let's go to public index.html, and let's put it right here. In fact, let's get rid of this comment. Let's get rid of all the comment. Let's get rid of this as well. Okay, so in the head section right below all the links, let's put it here. Okay, so we got the bootstrap material CSS. Now that is all we need actually, but let's also use all the JS as well. This will help us later when we want to view our application in mobile screen. For example, if you want to view your application in mobile screen, you don't get such hamburger menu if you don't have the JavaScript included. Okay, so I'm sure you want that, so why not bring in all the JS as well. So let's copy all that, come down here, and just before the ending body tag, let's put it here. Okay, perfect. Now we got material CSS as well as all the JavaScript we need, which includes a slim version of jQuery, Popper.js, material design.js, and so on. Okay, so that's perfect. That's all we need for styling. Now in the next lecture, let's set up GraphQL client and make our very first query to our server to load some posts. Now at the moment, let's one last time have a look, and you can see the font has slightly changed. If you can notice or not, it is because we are now using bootstrap material. All right, I'll see you in the next lecture. In this lecture, we're going to set up GraphQL client so that we can start making queries to our GraphQL server and get some data. All right, so we're going to do all that here in the app, and then we're going to slowly improve our application. We will learn as we continue with this course. Okay, so here the first thing you want to do is you want to bring in the Apollo client that we already installed in the previous lecture. If you skip that for some reason, make sure you install Apollo Boost, GraphQL, and add Apollo/React hooks. All right, so let's bring that in. Import Apollo client from Apollo Boost, and we also need to bring in GraphQL. Import GQL from Apollo Boost. This package contains all these packages. All right, so now we can create a client. Const client equals to new instance of Apollo client. All right, this is a function, and then it takes some arguments. For example, we're going to give the URI, and the URI is going to be the URI of our server, which is localhost 4000/GraphQL. So a GraphQL API endpoint, that's http://localhost:8000/GraphQL. Right now, I would like to move this to environment variables so that when we go to live production later, when we deploy our app, we don't have to go to each pages like this and manually update the URL. So let's utilize the environment variables in our React application. Okay, for that I'm going to go to the root of the this project, not inside source but inside here in the root. Let's create a new file called env. All right, so in create React app, whenever you want to utilize environment variables, you have to prefix your environment variables with react_app_. Okay, so this is a requirement, so make sure any environment variables start with react_app_. Okay, so here I'm going to use GraphQL endpoint. Okay, so that's going to be this one we have already written. Let me get rid of that. Let's cut it out from here and put here. Okay, Beautiful. Now we can use this variable instead. Close this. Okay, so we can grab that using the process.env dot this variable name. Okay, so this will give us whatever value we have here. This one. Actually, let's get rid of the quote here. Okay, perfect. Now whenever you add anything to your environment variable, you need to restart your server. That's really important. Okay, so let's do that. Okay, so we have the Apollo client GraphQL. We created a new client here. That means we are ready to make a query. Okay, so to make a query, the first query we're going to make is to get all the posts. So if you remember, if you go to our server, we have a type definition here in the post. We have a query type called, we have a mutation here, we have input type, we have query. I think we should put it below just to make things a bit more easier to read. Cut that out, put here. Okay, so we got the post type, input type, and we got the query. So we have this query called all posts that will return all the posts which we have here hard coded. Okay, so let's make this query. We can even give this a try using GraphQL Playground before we actually try from the React application. So localhost 8000 GraphQL. It's not working because we haven't been running the server. So let's open another terminal window here. Leave that running. Client is running as well as server. Okay, so I'm going to put server here. Get inside, get back. Okay, get inside server and npm start. Okay, great. Okay, so we can query all the posts like so. We don't need any environment variables or anything like this. We can simply do that and we get the array of posts. Okay, so this is what we want to do from our client, and you can even copy this. Okay, but let's write anyways, doesn't matter. Okay, let me close this. Let me go back to client folder. Here in the app.js, let's make a query. Okay, so we have this function app, which is a component, and I really like to make it a const app equals to use arrow function. Make it much more easier to read. All right, so here let's create a query all the posts, put in a state variable here, and then we render all the posts. Right, so we're going to utilize state here. So let's bring the use state hook from React. Use state. So we create a state here, const state, and to update the state we're going to use set state method, and that will use state function, and by default it will have an empty array. Okay, in fact, instead of state, I think we should call it post set posts. Okay, so here we're going to make a query. So client, we have the Apollo client here, so we use that client dot query. We want to make a query. Okay, so this is a function. It takes this argument. So the argument is going to be query. So this query is going to be GraphQL query. So we use GraphQL and backticks. All right, and here we're going to write our query just like we wrote in the playground. We wrote all posts and we pick these fields: ID, title, and description. Let's do that here. All posts, and we select ID, title, and description. All right, so this is our query. We're making this query using the Apollo client, and this will give us the result. Okay, so this will give us all posts. data.all-posts, and then that will contain the array of posts. Okay, so here once we make this query, we can use then, because this gives us the promise, so we can use then and catch. So then we get the result. Okay, so once we get the result, we can set post here in the state. At the moment it is empty, but we would like to populate with the post, right? So those posts are here in the result. So set post, that's going to be result.data.all posts. Okay, and that's all we need to do. Now we have all the posts that is written from this query. All those posts are here available in the state. Okay, so I quickly realized I did one mistake here. As you can see, if you visit the page at the moment, you will see unexpected name all posts. The reason for that is when I make a query like so, I have the GraphQL backticks and I have written the all posts. In fact, this should also be within the curly brace. Okay, so please cut that out. Okay, so inside GraphQL backticks, let's have a set of curly braces and then paste that here. Okay, now when you're working with API, whether it's a REST API or GraphQL API, whatever API you are working with, always make sure to check out the network tab. When you're working with API, always go to the network tab here. Okay, so this is one of the most important thing working with API, whether it's a REST, a graph, or anything. Okay, and you might even want to refresh the page once you are there. Okay, and you can see here I have this GraphQL query, which means this request was sent to our server, and in response we got data. Okay, so you got data.all-posts, and it has all the posts that we requested. Even headers here, you can see in the headers, you can see the request URL. So we made request to this endpoint. So sometimes by mistake you might not have the right URL, you might have some values undefined, it could be anything. All right, so always check the headers. If you're sending some token in the header, that will also be available here. At the moment we don't have anything. All right, always make sure to check the headers and preview. Okay, so we know that we're getting the response data.all-post. We grab that and populate in the state, set post. Now we should have post in the state. We can quickly have a look at that. Let's get rid of that and let's use json.stringify post. Okay, come here, and now we can see we have two posts. Let's finish this lecture by rendering these two posts. So here, instead of json stringify, let me actually get rid of the p tag and let's use a div. Now that we can use bootstrap class name, let's use div.container. All right, I would like to give a bit of a padding all around, so padding 5. So here, let's loop through all the posts we have in the state. So post.map, we're going to use a map method. Map takes a function, and I'm going to use arrow function here. So function, arrow function here. So when we're mapping through the post, we get the post. Okay, so here we return a div with a key. So each element here must have a unique key. So when we map through them, we get each post, and each post have the unique ID. So we can use that as a unique key, post ID, and then here we can show the post title. Let's not worry about all the fields, let's just show title here. All right, let's come here, and you can see we have post 1 and 2. Why don't we render the entire data? All right, so we have container. Let me get rid of that. Let me cut this out. Okay, let's create another div with the row, class name of row, and here I'm going to have a bit of a padding all around, padding 5, and here let's paste that back. So we looping through all the posts, and each post that we get, we're going to display in a card. Okay, let's cut that out. Div with the class name of column medium 4. Okay, so we have a 12 column grid, a row fits 12 column. So each card we will show in the 4 columns. So full screen will have 1, 2 and 3 columns. Okay, so column medium 4, and inside this column we want to show a div with class name of card. Inside this div we're going to have card body, card title, all that stuff. So let's create a div with card body. All right, so in the card body we're going to have card title. Okay, so here we're going to show post title. Maybe we can show that in h4. Okay, so that's the div for card title, and then right below we can create a paragraph tag with class name of card text, and we can write here post description. Okay, now we're looping through each of the posts. Let's make sure to give the unique key to this div as well. So key post.id. Perfect. This should look better. Let's give this a try. Perfect. Again, now we are showing 2 posts, 2 hard-coded posts, but very soon, maybe a bit later, not very soon, because we have to do the authentication as well, but soon we'll have real posts coming from the database as well. At the moment we are instantiating a new Apollo client and making a query like so. Now this is not practical when you have many different components. You cannot create like this on each and every component and just make a query and mutation and so on. That is not really practical. So what we're going to do is we're going to set up our app component as a wrapper component that will wrap our all other components, and we will make the client available as Apollo provider. All right, so that way this app component can be used as a wrapper component which will provide this Apollo client to the entire components of our application. And not only that, later we can even add React router, browser router, and that can also wrap the entire components. Okay, so this is going to be kind of like entry point for our entire application. So we are showing all the posts here, but this code can move to some other page, probably a home page or something like that, right? So why don't we do that? Let's copy everything. Okay, select all, copy everything, and here in the source let's create a new folder called pages, and inside pages let's create a page called home component.js. Okay, and I'm going to paste everything down here, change the name from app to home, come all the way up, change it from app to home, and let's leave it like this for now. We'll come back to it later. We just moved the code from app to home. Okay, now let's go to app. Now I want to make this as a wrapper component that will provide Apollo client for the entire components of our application. Okay, so the first thing you want to do is create new Apollo client, which we already have here. Then here we have this app component. Now we're going to get rid of all this. We're not going to do any of this. We're just going to return. So the entire div, we're going to get rid of all that. Instead, we're going to return app. Sorry, not app, the home page that we just moved, right? So let's bring that in. Okay, so all the components that we will use in this application we will import here, so that we can even implement the routing system later using a React router, and we can wrap the entire components using the browser router component that is provided by React router later. At the moment we just worried about making the Apollo client available. And for that, we're going to first bring in the component home from /pages/home. To make the Apollo provider available, we're going to import Apollo provider from at Apollo/react-hooks. So we got Apollo React hooks. Now when we return this app, we're going to wrap everything inside Apollo provider, and here we are importing home component. Okay, so we wrap the home component so that home component has access to the Apollo client there. So here we're going to provide client, pass the client as props. As you can see, we moved all the previous code that was showing all the posts to home page, and instead we using this app component as a wrapper, and it is at the moment wrapping only one component. That's all we have at the moment, and it is providing the Apollo client this way. That means now we can go to home, and instead of making query like so, we can use query hook now. Okay, so let's get rid of that. This is not the best possible way to make queries, mutation, and so on. All right, so what are we going to do here? We can make use of use query hook, import use query from at Apollo/react-hooks. All right, now we're going to write our query in a variable. Let's call it get all posts equals to. We're going to use graphql backticks, and within here let's use curly brace, and we're going to make our query for all posts. Okay, so we get ID, title, and description, just like we did earlier. So this is the query we want to execute. Okay, so we don't need this state as well. With GraphQL client, we don't need to manage the component state most of the time, and even the global state we can manage using the caching system, which we will look into later. But at the moment, let's just continue with this one. So previously we had this variable to show all the posts, store all the posts, and render here, but we're going to directly use the use query result here. Okay, so const data, we get the data when we make the query. So use query hook, and this requires the query, which is here in this variable. So let's pass that in. Okay, so this will basically make a query, this query, which means it will go to our GraphQL server and fetch all the posts and make it available in this variable called data. Now to give this a try, instead of post, you can do data.map, leave it post, doesn't matter, and then you just continue as it is. It's no problem. And even actually let me just show this to you. Map not defined. Okay, so not only data, we also get loading as well. So loading and error, we get all that. So if we have if the state is loading, we can return, let's say, paragraph with class name of padding 5 loading p-5. Okay, if it is loading state, we show loading, we return. So when we return, nothing, this code will not execute, it will end here in this return, but if not, then it will go there. Data.map is not a function. Okay, that means that's right, because we're not getting data, we getting data dot all posts dot map. Okay, now again in that situation, as you can see, now it works. Again, anytime there is an error, like you saw, we had this error, let's say. Okay, this type of errors you will get all the time when you're working with the API. So you get something like this. So the first thing you should do without thinking about anything else is come back here in the network tab. So you see all this. So if it is confusing sometimes, just give it a refresh. Okay, you might still get too many of them, but click on the one that looks like the right one. I guess you just try a few of them. So when I try this GraphQL, I can see here I'm getting all the data. Okay, so that means the request has been successful, the headers is right. Then you can look into somewhere else, but at the first thing you do is always look in the network preview. That always helps. So this makes sure that we have received the data in the client side already. Okay, so that means we were trying to loop through the data, but obviously map is not a function. Map works in the array, and we didn't have the array here. We have the array only when we access data.all post, which is also something you can see here, data.all post. All right, so this is the most valuable thing when you're working with API, please. Okay, so with that, we see all the posts. Beautiful. Now, throughout this application, this is the approach we're going to take. We're going to use query hook. We're going to use mutation, use subscription, all these hooks that helps us write better code. We're going to move these queries in a different folder as well later. We're going to write very well organized application. Okay, so loading, it might happen very quick that you might not even see. Let's give it a try. For very brief millisecond you might see that, but if you really want to see that, let's try. Let's go to network. By the way, you don't have to do it, I just want to show you. You go to this, click on this online and try slow 3z. Okay, now let me try this time. We might see loading here. Okay, it seems to be a bit too slow. Okay, we see for a while and then we see the post. So over the course you will see how powerful this Apollo client is. That helps us avoid having to write local component state in most of the cases, and even manage the entire application state using the caching system, which really helps to not totally avoid, but to minimize the use of state management, something like Redux. All right, so you will see how we all go with that. Maybe from the next lecture we're going to start working with our authentication system, because not just queries, we want to be able to create new posts by the logged in user, save in the database, do all that stuff, and for that you would need the login system, right? So that is the one we're going to focus on in the next section, and that means we're going to take a pause, take a break from GraphQL for a while, because we will be dealing with our client-side React application and Firebase. Okay, so for a while take a rest, but once we get back it will be full-on GraphQL. Okay, but so far you already got understanding of GraphQL and you're already starting to feel comfortable with GraphQL. I'm pretty sure with that, because you know now how to make queries, and you also learn how to make mutations using a GraphQL playground, right? So basically it's going to be the same, but when we actually have to apply it in the real world scenario using a client like React here, things get complicated, but that's why I'm here. Okay, so we're going to have that awesome journey, but after implementing the Firebase authentication, which is absolutely incredible, one of my favorite part of this course, because you don't want to write authentication system, forgot password, reset password, sending emails, refresh token, all that stuff you don't want to do by yourself and spend another 10-20 hours on this course for that, right? So we're going to use Firebase, which makes everything incredibly easy, handles everything for us, and it's just beautiful. All right, and this is very good. You're going to use it in real world. Firebase authentication is completely free as well. unlike any other service of Firebase, this one is completely free. All right, so that's coming next. But in this lecture, I want to show you one more thing, and that is using use lazy query hook. Okay, so this is completely optional, but I think you will find it quite useful, especially when you're learning. Sometimes you might want to do something on the click of the button. Okay, for example, you have a page, you might have a button. When you click on the button, you might want to fetch some post or get some data from the backend. How would you do that? Because normally you can see here what's happening here is it's all happening by itself. When the component mounts, everything happens. So you don't really get to understand how things work behind the scene. So when I was personally learning, I was curious, how do you do it? It sounds quite simple, but how do you do it, right? When you click on the button, only then you want to fetch some posts. So let's see how we can do that using the another query which we're going to use here, called use lazy query. Okay, so the concept is quite similar. Just like we had the use query hook, we're going to also use with use lazy query. It's going to take the query which is here in this variable, the GraphQL query, to get all the posts, and you still get the same information. You get the data, loading error, and not only that, you're also going to give this function a name, because when you have a button, let's actually write the button here. Okay, so let me have a horizontal line here, and button, class name button, button raised. Let's use some material style button, button primary. Okay, so let's say fetch post. I guess that's the name of the button. So on click, you want to execute some function, right? So let's use arrow function. You want to execute some function called, for example, let's say fetch posts. Okay, you want to execute like so. So that means you need a function that will fetch the post, right? So basically that should trigger this use lazy query, this query. So how do you do that? It's quite straightforward. Just like in React state, you have the array. Let me quickly show you. Okay, so if you have used React use state before, for example, you might have data, you have the method set data, both of them in the array, and then you have use state and you have something there, right? So it's a similar concept here. This data you will wrap in the array. So the first one is going to be method. Just like we have the set data, we're going to have a method, and we named that fetch post, right? We named that fetch post. That's the first argument. Second argument is the response. This is the response you get from this query. Okay, data, loading, and error, so on. So I wrote this line here thinking that it will help you understand this code. Okay, so let me get rid of this. Okay, so this is how you use lazy query, and you trigger this lazy query using this function which is here on this button. When the button is clicked, this will execute, and as a result we should have this data. Now there is a problem, because you can see here the naming conflict here. Let's see what error we get here. So the data has been already declared. So this is another issue you come across when you're starting to learn GraphQL. You see you want to perform more than one query on the page, but each of them, if they return the same data, loading, and error, how do you deal with this, right? Well, there's the easy fix. What you do is you can give it a value, any other value. For example, let's say, what do you want to call it? Posts. Let's call it post. Loading. Let's call it post data. Loading data, and error, loading error. You can do all that, but now for this time, let's not worry about loading or data. Let's just get the data and call that post data, and even probably just leave it post, just to make things easier. because we don't have anything named post, it should be good. Use lazy queries called conditionally. So React hooks must be called in the exact same order. Okay, we have the return statement here, so we should need to bring it down or take it up, because all the hooks must be on the top level. Okay, so let's put it here. Okay, so you can see here they're pretty similar, but you give it a name, give this as a function name, and you get the data, you rename that so you can avoid the naming conflict. Okay, so now it all looks good. Fetch post shouldn't be in each card. Let's actually take it out. Let's get rid of the horizontal line. So we have got container row, we got this div. Let me put it right after this div. Again, div with row, padding 5, and then let's put here. Okay, just so that it is in a different line. Perfect. Now if you try, we don't see anything. That's because we're not rendering those new posts that are fetched. They are called posts, so why don't we have a look at them here. Horizontal line, JSON stringify post. Okay, so these posts are here as a result of this button click, which executes the fetch post, which is this query. Okay, let's try. And as you can see here, we just loaded the post on button click. Okay, that's perfect. This is another thing I wanted to show you. These posts are loaded as soon as the component mounts, but even on button click you can trigger some queries like so.